gauge should I be using?
Yeah. And then 20/28 would be one choice.
Okay.
And then 20/26.
All right.
20/30. And then one more, 26/28.
All right.
Thank you.
Good luck on
Yeah, thanks. I think I'm gonna put this over here. Thank you, bro.
it. Yep. And I'll see you after work.
All right.
All right. I'll be out here for a little bit.
Okay. Yeah, that's a little better. On this great day, the seventh day, well, it's actually the first day. Well, I don't even know. So many different days, they're all the same. Wow. We got the SSG going right here. I was thinking about setting up a relay to swap the batteries automatically. Hello? Hello, hello. I think this coil needs an upgrade, so if you could vote on that'd be awesome, and I'll collect the tally at the end. I know that the optimal gauge probably isn't even in the stuff, but we're going post-apocalyptic, so we're only working with what we have right now. This is an SSG. An SSG is it's a circuit. Well, it's working on a tri-filer, 32 gauge and 20 gauge. As for what it is, you know, like what it does, I don't exactly know. I just know how to build it. I know that it can charge a battery, it can light a light bulb, it can do stuff like that. And as for anything beyond that, I'm not quite sure. Not really. Thank you. Awesome, man. Thanks. Appreciate that. I think it runs really good on 12 volts. This is a 12 volt system. You got your primary battery and your charge battery. They're both a little low at the moment, so I might hook up the primary battery as a power supply and change a connection in the SSG so that I can do that without there being like some smoke. Because the SSG is designed to pick up the negative energy, the negative spike. So you block off flow to the positive node and it all goes to the negative. That's how it's designed. But you can't hook up a power supply to that system. You got to change the one that goes to the positive, and you got to connect it to the emitter. Yeah, I don't know how to solder real good, so it's all alligator clips currently. But it's all logical too. Every single solder point has a connection. Every single connection has a solder point. Or a breadboard. Speaking of breadboard, I think I found one that will fit on my electromagnetic rotor so that I can hook a Hall effect up to it. Right now it's running on a reed switch. It runs pretty good, but the reed switch dies. It burns out often. Gets stuck. You know what I mean? Kit Kat, man. You're a freak, dude. You do a backflip. Without a trampoline, homie. Without a trampoline. This is not like, and you know, I feel kind of bad that I don't have all the necessary tools to put together this in a more minimalized effort. Happy Sunday, ladies and gentlemen, and on the 7th day, the one that lasts forever. Every day is the same. And even if I did a backflip, you wouldn't be able to see it. Alright, I'm going to change it up real quick. See, look at that. Now I'm kind of glad I didn't solder it because I can change it at my whim. Alright, this is 18 gauge. That was a 20 gauge that we were just watching. Now I'm going to do the 18 gauge. Oh no, wait a minute. This is the bifiler. Let me do this real quick. Gotta change this one now. Right here. Glad I caught that. All right. 18. Here we go. SSG. It's an SSG. Directly connected. Yeah, I don't, excuse me. I have caps, but I'm not using them right now. I have a nice cap bank over there that I could use. I'm not exactly sure like what cap I would use, what size cap. So this is SSG, ladies and gentlemen. Simplified schoolgirl circuit. If you want a schematic, look it up. It's a well-known build. That's wrong. Let me get this. There it is. So 1300 RPM. 80 volts. I have a 63 volt. I have a 400 volt. I have a 25 volt. We're going post-apocalyptic, so if I don't have it, we don't have it. Let me think about here. Well, it's 2.7 volts, but they're in series, so it's like 16 volts. Here's my 63 volt, but it's only 4700. Got one of those. I actually have a bunch of these. Got this bad boy. This is 500K UF. Let me see if I can find that one. Oh yeah, this is a bad thing right here. 1,000 micro. It's only got 1,000 though. That's the thing. It's way different than 1,500 or 15,000. Sorry. So that's awesome, man. This is actually not doing very well because the battery's so low. See, this is the primary battery, and it's almost getting to the point where it's not going to have a negative spike to it. Hello. How's it going? Chat. because that spike gets smaller and smaller as the voltage goes down, and that means this one charges less and less. But you know, it will continue to charge, as you can see. Maybe you can't see, I don't know. Can you see that? Alright, I'm going to go check the pole rating real quick. That's what I was thinking too. 20 and 28, man. That's going to be awesome. And I'm going to make it inductance. So it's going to have this diameter right here. It's going to be that and this, like this round. And then it's going to be like that thick. It's going to be like 2 inches deep. So we're going to get a lot of inductance and a lot of power. It's going to be awesome. So what I'm going to do in a little bit is I'm going to swap those leads for these leads, and we're going to do one of these things with the batteries so we can start charging up the one that's being used right now. I am going to set up a relay to swap the batteries automatically. I do not. If you can explain to me what an inverter is, maybe I do, maybe I don't. I'm not sure if I do or not. What is it, like just a connection? See, I'm good with connections. I got taught how to build this, like, it took a week for them to explain it to me online, like 2 streams. But within 2 streams, I knew how to build this. Didn't even know what it did, really, or what it's for, even. But that's awesome, man. So, the inverter, what's it do, man? What is an inverter? Flash me a link, man. I might buy one if I can do that. Actually, no, that would go against the rules. And the rules are we're going post-apocalyptic. That's why there's no 24 gauge in the pole, because I don't have any. Yeah, but, no. I don't have any. So this is the SSG circuit. We got our primary battery. We got our charge battery. We've got our trifilar coil. We're running off an 18 gauge drive right now and a 32 gauge trigger. We got a 100 ohm resistor on the trigger. And yeah, the third gauge wire is 20 gauge. And we were running on that when we started the stream, the 20 gauge. And it's all right, man. I have no technical knowledge. You know, like, for instance, if you say inverter, I have no idea what an inverter is, what it looks like, what it would be called if I wanted to buy one. Inverter. I'll type in inverter. That's it. That's simple. Sometimes it's not that simple, though. You got to realize when you say spark gap, I tried typing spark gap into a search engine, And oh my goodness, man, it's not. What is it? What is a spark gap? So we got SSG. We got primary battery right here. It's dwindling. That's all right. We got charge battery on this one, and it's going up pretty steadily. Now, if the SSG has a light in the circuit, like a neon bulb, I put a halogen bulb where the neon bulb goes. It's 120 watt or 120 volt filament bulb, halogen style, and it works wonders. It's awesome. It's like it's like hanging down here. It's down there. And that one goes across the emitter and the collector. And then there's a diode in here that goes across the emitter and the base. And then there's another diode that prevents the energy coming out of the positive. Which battery is it? This one. Of the charge battery. Okay, so it blocks the energy from coming out the charge battery right here. And then everything's forced to go into the negative side. Oh, yes, I might even have one of those, actually. It's a little transformer, right? Takes the DC and amplifies it, basically. Can go up to 345 volts. But yeah, it takes like 10 and then some amps and turns it into whatever you want, basically. That's what it is. I didn't know that those were called inverters. I do have one somewhere. I'll have to dig it out. I might have burnt it out, actually. But it's like a little square unit like that big, and it's got caps, and it's got a little transformer box on it, a high voltage. Mm. Yeah, I'll have to find all the ones I have and test them. Thank you. Thank you, Nazareth. All right, let's see how much of a charge this battery is going to hold. It started at 12 even. I'll work on swapping the leads real quick. Wow, man. when you're like, how did it even get like that? All right. All right, now this one should run a little bit stronger. Because the voltage is a little higher. But that's what the relays would do automatically. But I gotta find them. You know, I put all my stuff away and now I gotta find what I need. Had to clean up a little bit, you know. Oh, neat. You make it? That's awesome. You know what? I'm gonna hook up the series connection real quick. Yeah, it sucks. This is not good. So I'm gonna change it again. But it's supposed to cost less to connect more wire. Uh, or maybe I had a connection messed up. I'm not sure. But that was lackluster for sure. Let's look this one up again. You can hear that. That's awesome. It's an air core, but I use iron powder, iron filings for core material. So I fill this up with iron powder. Hmm. Neodymium magnets. There's 8 cubes on the rotor. North facing out. And then I'm using toroid, 4-inch toroid ceramics for the maglev. Time Machine. THYMEMASHINE. Time Machine. Just playing. Uh, if I got the relay set up on this, I'm pretty sure it could go for maybe a year. If I set up the time to the relay right. Not perpetual though. And speaking of relays, um, I heard the higher the frequency of your relay, the better your chances are. So I'm going to probably time it for a second. 1 second. I'm going back to 20 gauge real quick. All right. See, and with the clips, it's that easy to switch between 18, 20, and 18 and 20 in series. It's so easy. Neo air core is better. Oh yeah, the welding rods, man. I don't have any money for welding rods. Post-apocalyptic, bro. I mean, I know all that. I mean, kinda, sorta. Not all of it. I know some of it. I know that the copper covered low carbon steel welding rods are really good for core material. Yeah, I've been using, I don't even know, man. I'm gonna have a lot more luck without cores at all. Like air core, for sure. Sometimes I use a core and I couldn't even get the thing to move at all. It's like, that's awesome though. So there's not a too tremendous difference between 18 and 20. I mean, there is a difference, but it's very subtle. You spend more amps with the 18, you get a little bit more kick. I guess that kick is torque, maybe. I don't know, but you get a little bit more bump with every pass of a magnet with 18. And then the raw electric is just, I like the raw electric better, like without transistors altogether, you know? Because then you can really see what's going on. I mean, here it's obviously switching, but I mean, I don't know. There's just something more. I'll show you guys in a second, or maybe not. I could hold the magnet. That's what I'll do. I'll show you how easily I can switch between SSG and my other project, which is really cool. I think it's really cool anyway. I got all the electromagnets on the rotor, and then I use these Neos on the stator. It spins really fast too. It's awesome. I got the power supply, the switching mechanism, and the coils all on the rotor. So it spins basically freely. You just need that magnet on the outer edge. You know, I think there's something wrong with either the charging of this battery or something's not right with the batteries. Because I was using that one to run it, and this one was going up to like, 12.25. This one's not even getting up to 12.08. They're obviously, one's malfunctioning, kind of. Like this one depleted way faster than that one did. And this one charged way faster than that one does. It's weird. Something's leaking. Alright, we got 22 volts. I'm going to check the pole real quick. Nice. We still got 20 and 28 for the win. I think that would be awesome, a 28 gauge trigger. That would be great. Like that or 26, and I have both. So maybe make another tri-filer. Oh, you're talking about the relay? Yeah, I heard that, yeah, Kevin suggested that the batteries don't really like that. You can do it, but you're probably going to damage what you have. And that's what he said. And I'm like, okay, then maybe I won't do it that way. Maybe I'll swap something else so that it appears that the batteries are swapping. Or you put a third relay phase in where the batteries are totally disengaged, and then you swap from there. So it goes dot, dash, dot. And that dot and that those two dots are on and the dash is off. Now see, there's me with one of my ideas that I don't know how to do it. I don't know how to make that third phase actually happen. You got to do it on a timer somehow. You got to set your relays up to a timer, and it's got to be a second or so for each phase. So it'd be one on, one off, one on, and that would be a circuit or a revelation. That would be a revolution. My bad. Get a wall charger. Charge the batteries up real good and then use them. I had one. I just, of course, don't know where I put it. Alright, so this is how we do this. I'm now going to hook up the power supply. So you got to change the SSG from a negative collector to a positive collector in order to utilize the power supply to charge the battery. But you can use the same circuit basically, you just have to change what I just changed. All right, let's see what we can do here. Make sure we're just checking it out. All right. The diodes that I'm using in this are UF4007s. All right, so we're getting some charge, it looks like. Now we're charging this battery. I'm not sure how well this is going to charge with the power supply, but looks like it's doing all right. Okay, I'll check it. I'll check it out. If it's, I'll try and find. I call it a transformer, but I'll try and find what I got, and we can check out whether we can do it or not. Now hold on a second. I have these things that I got attached. See now, this is my coil rotor. Huh. It has two of these cap banks on it. It's awesome, man. It's so cool. And yeah, I have 4 pickup coils hooked up to those. And when it starts spinning, those pickup coils dump energy into those cap banks. And they filter in. It's the battery and everything's all hooked up into the same cap bank. I mean, you gotta have the battery going, but you can get a lot more speed and stuff out of that. See, look at how small the coil is, though. It's pretty tiny. It's only 300 turns of 18, 20, and 32 gauge. That rotor's nice, though. Yeah. So that's the circuit right there. We got lots of stuff hooked up to the transistor, but it all makes sense. It all makes sense. And then there, see this little apparatus right here that the transistors in it elongates the legs so you can hook more stuff up to it. or the pins, I should say. I like calling them legs though. So we're gonna charge this up to like, I don't know. I'll decide when to stop. And then we're gonna swap it over to the other battery. Bum bum bum. But you know, it's not like an instantaneous swap. We are gonna stop it before we start it up again. Yeah, I guess the ultimate objective of all this stuff back when it was being conceived was to make a thing spin forever, was the goal. And that is not my goal. I just wanted to make it spin without me spinning it, you know? That's all I wanted to do. I started out making magnetic discs that basically just levitated on each other. They were like handmade toroids. No, it's a trigger strand. It's a 32 gauge trigger in this coil right here. Now my other build has a reed switch. I use a reed switch to run my other build. But after the stream here, I'm going to start wrapping. I'm going to print the bobbin out for the coil. And then I'm going to start wrapping that coil. 20 gauge and 28 gauge it looks like. Okay, yeah, man. I'm all ears. If you can get something for me to look at, maybe. Um, I'll see. I don't know. I can't guarantee when I'll be able to do it, but yeah, it sounds like it would be really interesting, allowing me to charge the primary battery and not have a secondary. That would be awesome. But let's take a look here real quick. My 28 gauge, my 20 gauge. I got, you know, basically a full spool, 3-pound spool of each. We're gonna make ourselves a nice Bedini coil, a nice rotary flux coil. It's gonna be great. Okay, so it's a basically when you're winding your drive coil, you take another strand, and with your drive coil you wind that other strand with it, so that your drive coil and your trigger strand now are both the same length. So what you do, you don't have to twist them. You do not have to twist them. You can definitely twist them, but you do not have to, and it will work semi-quasi just as well either way. But I do admire somebody who will go through the rigors of twisting a full bifilar, man. That'd be crazy. Like, not crazy, but like the amount of patience that would take. If you don't have a machine to do it, that would take a lot of patience. But yeah, so you just wrap the two wires simultaneously in your coil. And then you got to remember, you got to mark where you start. You got to mark, you don't have to mark where you finish, you just got to mark one. You got to usually mark where I start, and that way you can hook your coil up correctly. And when I wrap, this is it right here. A buddy of mine, 007, 007. Now, what he did is he taught me how to wind a coil. All right, so you wind it, you start and you wind it to one direction, 100 turns. You go back one turn to go all the way back to this where you started, and then you do another 100 turns. And you go back one turn, and then another 100 turns, and then back one turn, and another 100 turns. So your whole coil is basically wrapped in one direction. You polarize it in doing so. So you don't, when you're going back to where you started, you don't do 100 turns back. You just do one. No, this motor does not self-start. It can. You got to hook up a cap, and you got to pre-charge that cap. But yeah. Or you could use a switch. You could use a switch in a closed position, and then flip it on, and that'll work too. But as for it just, like with the flip of if you're going to do the flip of a switch thing, you need a switch that's in a closed position when it turns on for it to start on its own. I don't care what kind of switch it is, it's got to be closed. And that's how you do it. All right. All right. Sweet. 12:30. We're going to see how much of this we maintain, that we keep. See, I shut the power off. It's already down to 12:24. All right, we're going to swap this though. Yeah, that's what I was just saying. But your reed switch has got to be in a closed position. Because if you start with it open, it isn't going to do anything for you. Now you can buy them normally closed. You can buy them so that they can automatically start your motor. All right. If you guys want to talk further about anything, check out my Discord. Go to the About page, click on the More, go to my channel, click on the More button. I got my email there in my Discord. Yeah, I don't think people like the fact that I tend to swear every now and then. The powers that be. Alright, so I'm going to charge up this battery and then I'm going to switch to my electromagnetic rotor. It shouldn't take very long. And then I'm going to build a vertical rotor. Let me show you the bearings I'm going to have on this beast. Hybrid ceramics. Well, see that missing bearing in there? It's not really missing. And with the vertical setup, even though it's very minuscule, that missing bearing is going to provide a gravitational speed aid. You know, that ball is going to roll and then it's going to fall, and then it's going to roll and it's going to fall. With having that extra space, it's going to fall. And then when it gets going real fast, it's going to make sure that none of the beads touch each other. And none of the bearings ever hit anything. It's going to be awesome. These are full ceramic bearings. They're very cool too. And just like this bearing right here, something got caught in it and that won't spin. I don't know. And that sucks, man. That's a full ceramic. All right, so, well, I don't know. Have we seen enough of the SSG? Do we want to see the other rotor? Or we want to charge this up to 30 and then let it drop? I don't know. We'll see. I'll do this for a little bit longer and then switch it up. Maybe I'll do another one. Maybe we'll take an intermission here in a couple minutes and then I'll do another one with the other rotor. I'm going to change out the reed switch. Could it already be blown? Yeah, it's already blown. Wow. Mm. I don't have any glue, so I can't, I have to hold it. But you get the point, right? I can't. I can't really. Not without glue. I don't have any glue. Ah! It'll speed up a little bit on its own. Maybe I can do the double magnet hold. You know, like. Alright, I got an idea. What's up, Caleb? Where'd you get those?
My friend gave me them. That one?
Nah, not right now.
Alright, I'll say some.
Okay. We're gonna get a higher perspective here. There we go. There we go. Now, gotta get our other magnet. Looking for a glue stick. I got some coming in the mail tomorrow. But, anyway, this is really cool when it gets going fast. But I might need 2 hands to make that happen. That sounds good. Hello, hello. Yeah, that's basically the idea. Now I can put 24 volts through it. I'm going to try and offset the other magnet a little bit, get some speed. Yeah, you can feel that. Tiggs. Little baby. Oh, this is good. This is good. I'm gonna go get 4 more magnets. Oh, I wish I had some freaking glue. I'm looking for a glue stick. Oh. There it goes. But I have more of this size magnet. Like we can make something happen with this, because yeah. Hello, hello. How we doing today? I wonder. No, nothing will work. Nothing will work. Dang. Huh. But this 4 magnet vertical rotor that I'm building is going to be super spectacular, man. It's going to have these for magnets. Oh, dude, it's going to be sweet. awesome. So it definitely works at 180. Now I can build 2 more drive coils and have another 180. But I think they're all going to have to work on the same switch. "12 volts, man, this is sweet." Yeah, there's probably a couple ways that I could connect this to like a meter. One is commutator plates, another is a slip ring. So cool. I wish I had some glue. So this is the north end, and this is the south end. And we're in repulsion phase. It's a pulse motor, kinda. It's really just an electromagnetic rotor. It's running on a reed switch right now. It's battery operated. So I got the power supply, I got the switching mechanism, I got the cap banks, and I got the coils all on the rotor. Right now, nothing. It's stopped. If I add more magnets, I'm not using a Hall effect sensor, I'm using a reed switch. I've already tried different angles. I tried 90 degrees, and that doesn't work. Not very well. See, I think the magnets are too close together here. Or the switch doesn't rebound fast enough, I don't know. I want to show you what I'm doing here. But at 180, like on the coils, it works really good. But I'm thinking like if I set up, yeah, I keep thinking that if I set up 2 more at another 180 degrees, that it should work the same way, but the magnets get too close together because they're so powerful. I've got ceramics, but I don't think they're even going to work, really. Here, let me get them. Damn it. Gonna have to bust out the clamp. All right, ceramics. You know, I'm gonna get out the toroids real quick and see if that'll work. I'm gonna have to separate all my magnets again. Yeah, it's not gonna work, I don't think. But here, thank you, sir. I really am. Battery operated and virtually self-contained. I mean, you do need a magnet to make it work on the outside, but. And then I was thinking, I have two of these big magnets, right? And when you put like iron on one of the poles, that iron becomes that pole, correct? I have strips of it like this. So I was thinking that I would wrap it around like that and connect it with the two. You know what I'm saying? Like make a circle of that pole going around the rotor. So when it would hit the magnet, it would roll, just kind of float on that. Like, you know what I'm saying? I don't know if it would work or not, but it seems like something on my mind for sure. Yeah, I gotta probably use smaller magnets. Magnets that aren't as strong. But like I said, I was thinking about using these big magnets and wrapping iron all the way around it so that the North Pole, I don't know if that would work. But I want to find out, you know. I just need my glue. My glue's coming tomorrow. So this is as good as I can do right now. But as soon as I can glue stuff down, you're going to see some serious beep. This is just 12 volts. It's capable of doing 24. I think this is awesome, man, for 12 volts. It's crazy good, considering how small the coils are. It's 200 turns of 20 and 28 and 2 different coils, and it's all wrapped in series. So I got 2 coils at 180 that are wrapped in series. So when I put another 180 magnet over here, it's double the whammy for, single the price. And then it'll stop. These reed switches blow like pretty often. But I'm going to charge the batteries. Or we could do this. Go 24. Oh man, I hate that. There we go. Now look at the size of that. It's a tiny little thing. I'm gonna give you guys a different angle real quick. That's probably what the problem is. Here we go. All right. That's pretty sweet though, isn't it? I think I'm gonna hook up a Hall effect sensor to this thing. That's gonna be the ultimate end game for how it's gonna run. And where did I put that thing? This is how I'm gonna do it. I'm not gonna put this on top of one of these cap banks. I'm gonna put the transistor in there. Just a standard connection. And hook a Hall effect sensor up to it. Thank you so much. Thank you, thank you. Those are 1-to-1 clips. The smallest clip I could find. Basically connects 2 wires together. Yeah, they do look like Legos. All right, so let me show you the Hall effect I'm planning on using. This one right here. Narrow that wire down to something that'll fit on here. And then put it where, right here. Put it like right here.
Here you go. I'll put it right here.
Yeah, plumbing. Yeah, man, it's a gravity sump pump. See, that's the thing, man. I don't appreciate people that think I need to have a purpose to build something. If I just want to build it for the F of it, I'm going to do that, and I should be able to do that without people scrutinizing me. And scrutinizing is the wrong word, without people judging me. You're like, if you don't have a purpose, you shouldn't be doing it in the first place. I don't know, man. I'm not saying you're one of those people. I'm just saying I don't like that. That is speaking of waste, saying that to me is a waste of your breath, a waste of your finger strength. All right. And thank you so much, ladies and gentlemen. Peace out. Have a wonderful night. Please subscribe. Bye now.